I shouldn't eat.
All right, guys.
Why am I oh, dude.
Hey, eyes up this way. You'll notice we have a fraction of 1/5 plus 1/7. We add those up. We have to get the common denominator. Creates 7/35 and 5/35. We have to get us 12/35. And what we want to do today is we're actually going to start with this fraction of 12/35. And we want to get back to what was the original fraction.
What am I doing?
And this is known as partial fraction decomposition. So we're going to work in reverse. We'll start from the actual sum and we want to break it apart into its pieces. That's really what we're doing today.
So what's it called?
Well,
Partial fraction decomposition.
how did you pick the 5 and the 7?
Because those are the factors of 35.
What is
Those are
there?
the only factors of 35?
Those 35 is a prime number.
Sorry, I don't know my rounds.
I'm sorry. 35 is not a prime. It's factors of 5 and 7. 5 times 7 are the only two factors that multiply to make 35.
What if there are a bunch of factors to a number? So you
Then you'd have to include all those different factors. That's why I picked the ones I picked.
well, then on our homework card.
Homework's going to be different. Now, from a process standpoint, this then we're going to look at and say, what would I have to do to this problem to actually add them together? Well, don't I have to multiply this one by 7 over 7?
Yeah.
Multiply this one by 5 over 5?
Yep.
So 7a plus 5b over 35. And that is supposed to equal that 12 over 35. That really is kind of like a first statement. And so our focus now needs to move to this part right here only. And for that fraction pair to be equal, what part must be equal now? If you look at it, 35 is in the bottom of both of them, right? So now all we really have is the numerator parts that have to be the same. And that's where we're going to draw some equations.
Yeah.
So we write that 7a plus 5 times b equals 12. The numerators have to be equal, and that generates an equation. Now in this example, we only get one equation. So we will not actually arrive back at the exact numbers we had before. We can have what's called a family of solutions, or an infinite number of solutions here. Maybe a is 1, b then would have to be 1, and that's 7 plus 5 gives me 12. But maybe I want to choose 0 for b, then a equals 12 over 7 as a numerator. And so we can get all kinds of different answers. Last year when you worked with systems of equations, if you got an answer where it was an infinite number of solutions, in other words one line was right on top of another one, you just said infinite number of solutions and you went on. Right? Well, we're not going to do it that way in here. We're going to add a little different layer to it. I am going to take this equation here and I'm going to solve it for b. So 5b equals 12 minus 7a. Divide by 5. b equals 12 minus 7a over 5. And now we're going to write this down as a relationship where I get to pick a, an independent variable, and then the b value is calculated based on this relationship. 12 minus 7a over 5. So for whatever a I pick, now I can calculate the appropriate b and exactly get to the right relationship between the two numbers. Questions about that?
No, we do.
Well, for this one, that's all we do. Now let's actually see an algebra example.
So you're done?
We're done.
Okay, I understood, and so we just did this.
I know, this is different. Pick a number for a.
5.
5. 5 goes in there. Then we have 12 minus 35 over 5. That's the number that's the b number to create the exact fraction we have.
Oh, okay.
That's what that means. There we go. Partial fraction decomposition is made so that we can take a fraction that's combined and split it apart. We want to do this, well, pretty often actually, in our calculus classes.
Okay.
This is a piece of something that we'll do in our antiderivative calculus or integral calculus. And it's a part of a larger process. So I want you to get this part of that process in place, so when we get to that larger process next year, we can do the larger process much more easily than we can this process right now. I need you to factor that fraction, 1 over x squared plus x. What's the factors of the denominator?
1 over x squared plus 1x.
Oh, it's just sit here. I need wood and tissue, but I want to cross the path of the camera.
Talking to someone today.
You should do it right.
What are our factors?
Put your nose close. Wow.
What's the denominator factor to become?
1 over
x squared plus 1 over x. Or that.
Hey, what's our rule for factoring?
I don't know.
First thing we always look for is that
What
thing
you
that's a
take
common
out.
factor.
Oh yeah, that's right.
So we factor out our common factor. We end up with these two terms. Now we're going to show the split and say we're going to have some number, we don't know what it is, we'll call it A, over the first factor, x, plus some other number, we don't know what it is, we'll call it B, over the second factor. So that represents the split of the two parts. And that represents what the two factors are that are going to be decomposed, these two things. We want to find what is the number that's A and what is the number that's B. That's our goal. Yes?
How do you know which number to put a in? Like, I could put A for X.
This is an arbitrary choice. We could have put A over X plus 1 and B over X. And we'll still get back to the bottom. We'll still end up with the right numbers here and here. I'll show you how that works in a minute.
This sucks.
Hold your opinions till we get done.
Alright.
Okay.
A lot at the end.
So A over X plus B over X plus 1. If I needed to actually add those together, what would I have to do?
Get the common denominator.
Which is what?
Plus
X squared.
I mean, it's that thing, right?
Yeah.
So what needs to be multiplied over here?
X plus 1.
What needs to be multiplied over here?
X.
Does that make sense? But this combination has to be the same as what?
X.
Isn't this fraction right here going to exactly be that fraction right there?
Yes. Yeah.
So now if we focus in on this part right over here, what now must be equal?
The top.
Numerators, right?
Top. Yes.
So we're going to write A times X plus 1 plus B times X equals 1. We're going to write this line. That's where we're going to draw equations from. Would you agree that that's the numerators up here?
Wait, why is it
Where's the
plus
zero?
A? And the X plus
Can I
A.
distribute?
Ah. Gosh, that's...
Can I distribute?
Why'd you do it to the X though? Yeah.
Aren't there two terms here that are X terms?
Yes.
In order for them to be equal, don't they need to have a corresponding X term over here?
Sure. If you say so.
Well, it needs to be there. Because the only way these things are going to equal is if the parts that are X terms over here equal the parts that's an X term over here. And there's not one existing in the original problem. The whole is place value, that's a 0 times X. Are those all like terms?
Add them.
So we have an equation of AX plus bx from this side, and that has to equal the same x term on this side to equate the problems. Right?
Where's the A going?
Well, it's just a constant number, right? So that's a constant, matches up with that constant. Conveniently enough, A equals 1.
Why is there, oh,
How?
Put in the other like terms. Our x terms get put together, then our constants get put together.
So this whole time A equals 1.
Apparently.
That's better.
From that top equation, the x is common to all three of them, is that correct? We'll divide it out. We have A plus B equals 0, which implies that that B equals the opposite of A. But A equals 1, so B is equal to negative 1. Now at the very beginning, we chose a spot for A and a spot for B, is that correct?
Yeah.
A spot for A and a spot for B. So now we're going to replace the corresponding A and B numbers.
Everything turns out okay.
And there's the actual answer I'm looking for. That's the partial fraction decomposition of that first term, the first problem.
That's the answer. 3 hours later.